So what good is data if you can't get it quickly and efficiently where you need it to be? Couchbase provides a consistent approach to data access across all our SDKs. Let's take a look. So applications access Couchbase services directly, and as we've seen, the services interact as required to provide get set by document ID, query via aggregate views, query via nickel, natural language queries over your text, and access to long-running analytical queries. All nodes exposing a given service in your cluster are involved in delivering that service to your client. The SDK automatically knows which nodes offer which services and how to reach them through the regularly updated cluster map. Regardless of the programming language used, Couchbase SDKs provide a common set of capabilities and a unified approach. The SDK provides your connection pooling, encryption on the wire, JSON serialization and deserialization into relevant structures for the programming language in use, document create, read, update, upsert, and delete capabilities, both via nickel and direct API call, access to create and manage indexes built using either the index service or aggregate views, text indexing and search via the full text search service, access to analytical queries via the analytics service. You have your choice of either synchronous or asynchronous API calls for all operations, and the SDK provides a single point of contact regardless of ongoing changes in your cluster topology. Now, these capabilities are exposed in consistent APIs across all the Couchbase SDKs for Java, C#.NET, Node.js, PHP, C, Python, and Go. Check developer.couchbase.com for details, source code, and documentation. Regardless of the language, you'll find APIs to insert, creating a document and airing if its key already exists, upsert, which creates a document but updates it if its key already exists, replace, which updates a document, airing if its key does not exist because there's nothing there to update, and remove, which deletes a document, again airing if that key doesn't exist. But there's also an API to execute any nickel query you can imagine to select, insert, update, upsert, and delete documents as well, and to create indexes, to filter, join, order results, and much more, so you'll see there's overlap in those approaches. There are APIs to append and prepend text to a specified document, APIs to get a document by its key or to get and optimistically lock or unlock that document by changing its check and set value. There are APIs to touch a document and increment its time to live, or to simultaneously get and touch a document. And an API to get and manage a cluster-wide counter value, commonly for use in generating unique document IDs. Now, another aspect of this unified programming model is that you don't need to access full documents. Now, a document in Couchbase can be up to 20 megabytes, and depending on the model you design, you may not want to move something that large across the network. The subdocument API allows you to look up and mutate values at a specified path within a document without getting the whole thing. Now, if you prefer a higher level of managed abstraction, you could also work with our Data Structures API, creating local map, list, queue, and set objects. Update their local values, and the changes are written back to corresponding subdocuments on the server. Persistence from these data structures is fully managed, and the objects are implicitly created on demand. So how might connecting to a bucket and creating a document look like in practice? We'll take a look at this in Java, but you'll find the same approach across all our SDKs. First, you create a connection by pointing to one or more high-availability Bootstrap nodes in your cluster. After this initial connection, the client will be continuously updated with a map of all nodes and their services, and will manage those connections for you. Then you open your desired bucket. You could create a JSON object in some way relevant to your application. You create and assign an ID to that document, then pass it to the bucket. Here, an upsert operation will create the document or update it if it already exists. Then you can get that document by its key and access its values using an approach that's appropriate for the language that you're using. To learn more, check out our free online language-specific courses. What about best practices? Well, to keep pace with the way that data flows these days, Couchbase explicitly supports reactive programming approaches in our Java and C# SDKs. And of course, reactive approaches are inherent to Node.js development, and we have a Node.js SDK as well. These implement best practices in handling large data streams. A fast overview of this very interesting approach is available at the Reactive Manifesto website. Does Couchbase have broad community support? Definitely. We actively and enthusiastically participate in the open source movement. Our server, sync gateway, mobile database, and SDKs are all open source and available. Check this page for more detail and all the links to source. So what have we learned here? Well, the SDK manages your connections, documents, operations, and queries, and is automatically aware of your topology and service distribution. Couchbase supports SDKs for Java, C#.NET, Node.js, PHP, C, Python, and Go. And these expose a consistent API across these languages and environments for interacting with all your services. The SDKs also support subdocument and data structures APIs. Nickel is SQL for JSON, and, as you can imagine, provides overlapping capabilities with some of the document-specific operations. Your approach will vary based on your preference in your application. Couchbase enthusiastically supports numerous open source projects, including our primary products. And we support reactive programming approaches in Java, C# and inherently in Node.js. Next up, we're going to take a look back at the server at how Couchbase supports you in high availability and disaster recovery.